Okie doke team. Well, this is awesome. I'm looking at 1.3, and this is the worksheet B, just so you know. And 1.3 is all about solving equations with variables on both sides. That's what 1.3 is all about, variables on both sides. Now, by the way, the first worksheet, there was always a solution. There was exactly one solution, which we found. We found the solution each time. Worksheet B is weird, though. There's not always a solution, and I'll explain. So let's go ahead and solve this first equation, solve in quotes. So I'm going to go ahead and split this equation into 2 halves. And there's a variable term on both sides. I want to fix that first. So let's go ahead and do that. And if you notice that the variable term is exactly the same, then good, because that is what's going on here. So let's subtract 2x from both sides. On the left side of my equation, 2x minus 2x is 0. It cancels out. That was what I wanted to do. I canceled it out. I'm left with just 1. Let's carry down that 1. On the other side of my equation, I have 2x minus 2x. It cancels out again. Cancels out again. And I'm left with negative 1. So be careful. That is definitely negative 1 down here. Now, the variable canceled out on both sides, and I'm left with this equation, 1 equals negative 1 team. Is that true? No, that is not true. 1 is not equal to negative 1. So we call this no solution. That's what we call that, no solution, all right? So I've actually added a little something to our note sheet, okay? As always, the goal is to isolate the variable, and here's our steps, okay? At the bottom, I added this note. If the variable cancels out on both sides, if that happens, you're left with either no solution, like that example I just showed you. We had a false statement, right? 1 did not equal negative 1. So here's an example. 3 does not equal negative 10. That's false. So then I have no solution. Now, if I end up with a true statement, for example, if I get something that says 0 equals 0, like that's true, we call that infinitely many solutions, or as a shortcut, we write I.M.S, okay? All right, so let's do one more then. Let's do one together. So I'm going to solve this the same way I normally would. Let's split it in half. First step is distributive property. So I'm going to multiply 3 times x is 3x. 3 times negative 2 is how I think about that. It's negative 6 or minus 6. So that was 3 times 2 is 6. You can also just carry down that subtraction sign. And then on the other side, I have 3x minus 6. So 3x minus 6, I'm just carrying that down. Now, there's a variable on both sides. I don't like that. So I'm going to cancel out my variable on this side. Minus 3x, minus 3x. Cancel, cancel, carry down the negative 6. On the other side, 3x minus 3x cancels out. I'm left with minus 6. Oh my gosh. The variable canceled out on both sides. So I have one of these special cases. It's either no solution or it's infinitely many solutions. So is this a true statement? Is negative 6 equal to negative 6? Is that true? Yeah, that's true. So this is infinitely many solutions. Now, I'll also just point out to you, after you use the distributive property, if you notice, oh, hey, these are exactly the same equation on both sides. If you ever notice that, if it's ever exactly the same on both sides, then you know infinitely many solutions, just so you know. Okay, good. Here's what I would like you to do next. I would like you to try number 2 on your own. I would like you to give that your best shot before playing the video and seeing the solution. I'd like you to try it on your own. So go ahead and pause the video. Okay, let's use the distributive property on one side. Then let's use the distributive property on the other side, paying close attention to the fact that that was -4. So both of these items should be negative. At this point, if you're noticing that there's a variable term on both sides, and it's the same variable term, they're both -12v, that's good. You know this is going to be one of those special cases of no solution or infinitely many solutions. The variable cancels out on both sides, leaving you with a false equation. 30 is not -4, so this is no solution again. Okay, team, try number 4. Before moving on, try it on your own. Good job, guys. Okay, after I use the distributive property on both sides, if I'm very careful with my negatives, I will find out that it's exactly the same on both sides. After we use that distributive property, I get an equation that's exactly the same. And so I already know this must be infinitely many solutions. Okay, good job. My challenge to you all is to try each of these 4 on your own, and we will go over them in class tomorrow. Actually, I lied to you. Let's do one more. Let's do number 5 together. Split the equation in half. There's a variable on both sides. I don't like that. I want to fix that. So let's go ahead and cancel out this y term. Let's cancel this one out. Let's subtract 1y from both sides. And I'm subtracting because that's a positive y. The opposite of positive y is subtraction. Subtract 1y. On the left side, I have a cancel. Carry down the -12. On the right side, 4y minus 1y is 3y. Now, in this case, the variable did not cancel out on both sides, which means I actually have a normal, solvable, one solution type of equation. So let's divide both sides by 3 to cancel it out. I'm left with my y. -12 divided by 3 is -4. So this is one solution. Y equals -4. That is my final answer for number 5. Okay, so 6, 7, and 8, team, I would like you to try your absolute best on these, and then we will finish them up in class tomorrow. Okay, happy Wednesday. Bye-bye.